So this will be the solution to the conservation of energy problem. Let's just do a quick redraw so we can make sure we analyze it. There's the ground, and we've got some track. And what do we have? Here's A, B, (10 meters), (6 meters), (2 meters). So here's what we're starting with. The ball is rolling from A to B. It's moving 3 meters per second at A, and we know the distance along the track. So problem 1, if the track is frictionless, let's find how fast the ball should be moving at point B. This is a very classic energy problem. How can we recognize it? Well, it's not along a line, so it's hard to just deal with it with motion. But what do we have? If you think about energy, they deal with heights and speeds. So we have changes in heights and we have changes in speed. It's very typical to deal with for energy. So before we even start, what we should think about doing is what is the principle, what equations are going to we going to use, and then how are we going to solve it. So when we're looking at this, if the track is frictionless, so there is no non-conservative friction force. In fact, the only force acting on this ball is gravity as it rolls down the hill if we ignore friction. This system then for problem 1 interacts only through conservative forces, so we are allowed to use this equation. KE initial plus PE initial equals KE final plus PE final. So now that we've decided, what we want to do are 3 things. Label initial, label final, and since we're dealing with potentials, find the reference. So we're starting here. Here's initial. We're ending here. Here's final. So if we're going to have potential energies, we need a reference. This will be my choice. I am going to choose the reference at B, meaning that is where PE due to gravity is 0. So all we're going to do now are find zeros before we put numbers in. So we're going to ask ourselves, is KE initial 0? No, because you were told it was moving. Is PE initial 0? No, because you were not at the reference. Is KE final 0? Absolutely not. If you are looking for how fast it's moving and you call it 0, you can't find a velocity because you've already determined it's 0. That would be very, very, very bad. However, PE final is 0 because it is at the reference. So now we can put some things in. This says 1/2 mv0 squared plus mg y initial equals 1/2 mv squared. There's our starting point. So the first thing we notice mathematically, the masses cancel. There is a mass in every single term, therefore it cancels. And at this point we can just put numbers in. You could solve directly for V, but let's just put numbers in. 1/2 3 meters per second squared plus 9.80 meters per second squared. Y initial is not 10. Since it ends up 2 meters above the ground, it's 10 minus 2, or 8 meters. Notice also you do not use negative for G. There are no axes. This came out of mg. Make sure you don't put negative value of 9.8 in. This equals 1/2 v squared. So when you solve all of this, you will get the final velocity V equal to 12.9 meters per second. That's how fast the ball should be rolling if there was no friction. Problem 2. You are told the actual speed of the ball at point B, and we want to know the average friction force that acted on the ball. You are also given the mass of the ball. We can still use work and energy. However, we can't use the same equation as we did for number 1. Friction is non-conservative. Therefore, there is non-conservative work. The friction force does non-conservative work. So we are going to have to start our conservation of energy with a work term. We use this form. Work NC, KE final plus PE final, minus KE initial plus PE initial. So the way you want to probably solve this is to find out how much work is done. Remember, the only time in these equations you're going to see a force is when it comes out of the work term. So if we can find the work, we can then find the force. Well, the same zeros are going to exist. In fact, the only zero is PE final, just like before. So what do we have? Work NC is KE final, 1/2 mv squared. Now be careful, we have to distribute the negative. Minus 1/2 mv0 squared minus mgy initial. Do not cancel the m's out this time. There is no m on the left side. Do not cancel out the m's this time. Work NC, now we can put numbers in. And again, this is just going to be long, but let's see what we end up with. 1/2, 0.500 kilograms was the mass. You can't use grams. And the final velocity was given as 9.56 meters per second. Make sure we square that. Minus 1/2, 0.500 kilograms, 3 meters per second, squared, minus 0.500 kilograms, 9.80 meters per second squared, 8 meters. Let's keep putting numbers in. So let's solve each one. This term is 22.8 joules minus 2.25 joules minus 39.2 joules. We'll keep an extra fig in for now. So you have the non-conservative work equal to negative 18.65 joules. Let's make sense out of it. Why is the non-conservative work negative? If you look at the actual speed, it's less than what it should be because there is friction. In the absence of friction, it would be moving faster than what we actually have as a value. That means we have lost some kinetic energy and potential energy into fighting friction. So it makes sense that it's negative. It is a loss of mechanical energy given off as heat. So how do we get the friction force? Well, in the work term, remember what work is. Work is F cos theta delta x, that's negative 18.65 joules. Now we got to be very careful. The non-conservative work means this is the work done by the non-conservative forces. There is only one, which is friction. So let's put it in. The force is F. It moves delta x. The angle between friction and the way it moves at any instant in time is 180 degrees by definition. So now what do we have? This is, the cosine of 180 is negative 1. So the left side is negative F. Delta x is not 8 meters. Since friction is not conservative, it depends on the path. The path was given from A to B of 34 meters. Now we can divide, and we will end up, when we divide, going back to our 3 sig figs, we will then find that the friction force is 0.549 newtons. Yes, positive. Just like always, we are finding a magnitude of a force, and it should be positive.